Okay, class, now we're going to talk about section 3.3, which is about beginning to look at what we call truth tables for negation, conjunction, and disjunction. I'll explain what all that means in a little bit. So we're going to look at truth tables for the not symbol, for the and symbol, and for the or symbol today. Okay? So these are the three things we're going to look at. So a truth table is exactly what you'd expect it to be. Is we're going to look at how the logical quantifiers, specifically not, and or, affect the truthfulness of a claim. So if I have statements like, let's start with a simple example. So the most basic truth table is this one. If I have P and not P, and I'm comparing the two of them, okay? P only has, let's say I have a statement P. It's going to either be true or false. It can't be either, because remember we talked about that a statement has to have the quality that it is either true or false. So I guess the question becomes just simply, if P is true, what would not be P? Not P be? Well, not P would have to be false, because it's the opposite of P, right? And if P is false, then not P would be true. So that's our first basic truth table. Very, very easy one, because P and not P obviously are going to have opposite truth values. Okay, so basically what we're saying is P has two options, true and false. It could either be true or false, and let's see what happens to not P in those two cases. That's the first truth table. So this is truth table number 1. Okay, let's build our next general truth table. And to do it, I'm going to use a couple different statements just so it's easier for us to wrap our mind around how this is the conjunction truth table, by the way. Conjunction means using and. Conjunction means and. So this is the conjunction truth table. So we only have a couple ways that this could happen. And I'm going to use the book's order here. These P and Q could both be true statements. Okay? P could be true and Q could be false. P could be false and Q could be true, and the only other thing that could possibly happen is they're both false. Those are the only 4 possibilities of whether or not, of how P and Q could be true or false in combination with each other. Okay, so let's take a look at this. If it's true that I ate a pizza and that I drank a Coke, would it also be true that I ate... So now what we're going to ask the question here is, assuming that these two are true, would it be true that I ate a pizza and drank a Coke? Well, of course it would, because they're both true, correct? So true and true, a true statement and a true statement is a true statement. Because I did eat a pizza. We just assumed that I ate a pizza and I drank a Coke, so they're both true. And so the statement, I ate a pizza and drank a Coke, is true, because I did, in fact, eat a pizza and drink Coke. So this is true, a statement. The conjunction is true. Now let's try this one. Take a look here. I ate a pizza is true, but I didn't drink a Coke, because the second one was false, right? So actually, since that's false, the statements, I ate a pizza and I didn't drink a Coke. So is it true that I ate a pizza and I drank a Coke, which would be P and Q? No, it's not true. Okay, so this one's false. Same for this, same reasoning here. And then, this one's kind of weird. It's false and false, so that means I didn't eat a pizza and I didn't drink a Coke. Are both false. So the question of is, I ate a pizza and I drank a Coke would be false, because I didn't eat a pizza is false, is because it's false that I ate a pizza, which means I didn't eat one, and it's false that I drank a Coke, which means I didn't drink. So this is false. So this is another one of your basic truth tables. So this is in general the truth table for the conjunction with these particular combinations. Okay, we're kind of building these basic truth tables, and then we're going to use them as a tool when we get done. Okay, let's look at a disjunction table, which is using or. Now we're using or. So what we're trying to do is we're trying to look at, again, if P and Q have the values as outlined in this half. And, of course, those are the only four combinations. They could both be true. One could be true and one could be false. There's two ways for that to happen. And they could both be false. So let's think of this. If I smell roses is true. And I smell cinnamon is true. Is it true that I smell roses or I smell cinnamon? Yes, it is. I just have to smell one or the other for or. So this is true. Okay, let's take a look here now. If I smell roses but I don't smell cinnamon. So I smell roses is true. I smell cinnamon is false, which means I don't smell cinnamon. So is it true that I smell cinnamon or I smell roses? Yeah, because I smell roses. So or means it has to be one of the two has to be true. Same thing here by the same reasoning. As long as one of them is true with an or, the whole overall statement is true. Because or just means one or the other needs to be true. Or both. That's what or means. Now, if it's looking at the last case, if I don't smell roses, I don't smell cinnamon. Is it true that I smell roses or I smell cinnamon? No, it's not, because both of those statements were false, and in order for an or statement overall to be true, one of the two has to be true or both. So this is the general truth table for disjunction. Okay, so let's go and we can actually do some problems here now. So here are the two truth tables we just came up with that reveal that if, for example, just reviewing again, if, for example, P is false and Q is true, then the statement P and Q would be false, because one thing to recognize, guys, with a conjunction is the only time P and Q is true is if both statements are true. That's what you want to remember. Like if I say, I went to the store and I drank coffee, that statement is only true if both statements are true. If I didn't drink coffee, then that statement is a lie. So what we're trying to do, basically, guys, is we're trying to determine on the basis of whether I know the individual statements are true, is the compound statement still true, or am I lying? So we'll get more acquainted as we do examples, but these are the general tables. So now let's look at some examples. So the first thing we're going to do in any of these problems is we're going to start our truth table off very simply, okay? I'm going to show you how to do that. So if I do, as an example, let's say I tell you that P is, this is from the book, okay. Determine the truth value for the following statements. Okay, so let's take an example. First one. Let's do P or Q. All right, so first of all, we know, let's make a little small table, P, Q, and then P or Q. So we first write the individual pieces, which are just P and Q. And let's look at whether these are true or false. Well, it looks like P is true, isn't it? 4 plus 6 does equal 10. It looks like Q is false because 8 times 7 is not 72, it's 56. So that's a false statement. It is a statement still. It doesn't have to be a true statement, but it's false. So is it true that 4 plus 6, now if I wanted to say this in English, it would be 4 plus 6 equals 10, or 8 times 7 equals 72. Well, is that overall statement a true statement? Well, yes, it is a true statement because 4 plus 6 equals 10. Because remember, with an or, only one of the statements has to be true or both. Okay, so this is true. So that's my answer, true, for that one. Okay, let's try another one. Build to these harder ones. Let's go with not Q and not P. Okay, so what I first do is I can actually go ahead and make a table, not Q. That's easy to figure out, not P, right? And then I'm going to test what not Q and not P is. Well, not Q. Well, first of all, let's take a look at Q. Q is a false statement, correct? So that means not Q is a true statement because it's the opposite of Q. P is a true statement. So that would mean that not P is a false statement, the opposite of what P is. So if I go back to my conjunction truth table, which is what I'm dealing with now because I'm using an AND. Do you guys see how this connects up? I'm using an AND here. So that connects to this table. Well, if I have a T and an F, remember I said that AND only works when both statements I'm dealing with are true, but in this case, one of them is false. So I'm actually in this case right here, so my answer is F. So you just got to get used to using these truth tables and kind of understanding them. We've kind of derived them, so my answer is F for that one. Okay, let's look at some more complicated examples. I think you'll see how this works. So if I gave you something like this, that's a really complicated one. The way we start all of these problems is we start with our P and our Q columns with the basic template of they could both be true. This one could be true, that one could be false, this one could be false, that one could be true, or they both could be false. And then in each of these cases, we're going to determine some things. So first of all, let's build our table and let's slowly add layers. So first, let's calculate, looks like we're going to have to know not Q, right? Because that's one of my choices here. Then we're going to do what's in parentheses first, so that part. So the next thing I would calculate is P or not Q, which is the thing in parentheses. So I'm slowly calculating one step at a time. And then at the very end, I'm just going to need to know not whatever that is. So what I'm going to do is when I get this column, I'm just going to change it from true to false or false to true because of the not. Okay? So first of all, not Q. Well, looking at Q, if Q is true, not Q would be false. If Q is false, not Q would be true. If Q is true, not Q would be false. And this one's true. So basically, I just negated Q in each of those four cases. Okay, now P or not Q. So now we're looking at P or not Q. So we go to our truth table, and it looks like I'm in the true-false category for this first one, which means my answer would be true. Because remember, for or, as long as one of them is true, or both, the overall statement is true, as the example we did before sort of confirms. So this one would be true. Now we're looking at true or true. Since they're both true, remember I said for or, one or the other has to be true or both. So this one would be true. Okay. False or false, well that makes this false because neither of them is true. And then I've got false or true. One of them is true, so this is true. So far we know that P or not Q is true, true, false, true. And then now that I'm just throwing a not in front of this whole thing, I'm just going to change the not, just changes true to false or false to true. So this is false, false, true, false. So that's my truth table. So now I know that if both statements at the beginning are true, then the overall statement's going to be false. If both statements at the beginning, one is true, this one is false, then this is going to be false, the overall statement we have at the very end. If this is false and this is true, the overall statement we have at the end is going to be true. If this is false and this is false, the overall statement I have at the end is going to be false. Okay, this one's kind of long, but if you use these basic truth tables above, it's really not too bad. Okay, so notice what I do is I always start every truth table with just my basic P and Q, okay, which is this template right here. They could both be true. this could be true and this could be false, this could be false, this could be true, and this is false, and this is false. Those are my only choices. So now I got to figure out how to build my overall mess. So looks like I need to find both not P and not Q. Agreed? Because they're both in there. There's a not P here and a not Q there. Then I'm going to find this first one, which is P and not Q. That's this first one here. Then I need to find this one over here. That'd be not P and Q. Then once I find those two, I want to find the overall whole statement, which is, I'm going to label, that would be P and not Q, or not P and Q. Okay, so now let's go through this. It's really easy. Just start left to right, work through this. So not P just changes all the truth values of P. So that changes the true to the false, the true to the false to the true, and the false to the true. Not Q changes the signs of all the Q's. So this is false, true, false, and true. Okay, now P and not Q. So I'm going to underline P and not Q would be comparing this column with this column. Remember, with and, the only time that an and statement is true is if both statements are true. So let's take a look here. True and so this is the first one is true, T and F. So that one's a false because they're not both true. So this one's false. True and true is true. False and false is false. False and true is false because they both have to be true in order for an and to work. Now let's look at, now underline in blue, we're looking at not P and Q. So that's these two columns, right, in blue. You guys see that? Not P and Q. And again, and they have to both be true. Well, the only time they're both true is down in this column right here. All the other times there's at least one false, so they're all, the overall statement's going to be false. So now I'm comparing these columns, right? Because I'm doing the final statement, which is this beast or this beast. So I'm doing this or this. So I'm actually using the disjunction table because I'm using an or symbol. I know this is complicated, but it's not horrible if you get used to the symbology. So false or false is false. True or false is true, because remember with or, only one or the other or both has to be true. False or true is also true because there's at least one true. False or false is also false. So there's my overall truth table. Okay, again, we're always going to start with this initial template, guys, in all these problems when we're dealing with a P and a Q. And then we just work our way up. And notice how I broke it down in pieces. I started with not P, then not Q. Then I did this part, and then this part, and then I merged them into the or statement at the very end. And that's my final answer, is this list as it corresponds to this original template over here. Okay. Okay, now we're going to do one with 3 different statements in it, P, Q, and R, okay? And this is more complicated because since there's 3 different statements, P, Q, and R, there's lots of different ways that they could be true or false. So for example, just starting at the very beginning, they could all 3, just looking at this, they could all 3 be true, right? Or there's 2 of them could be true and 1 is false in these 2 ways, right? Or this is another example where 2 of them are true and 1 is false, right? Those 3 lines. So you could have P and Q are true and R is false, or P and R are true and Q is false, or Q and R are true, Q and R are true, and P is false. Those are the only 3 possibilities of having 2 trues. Then find all the possibilities of having 1 true. Well, here's all the ways of having 1 true. There's 1 true, 1 true, and 1 true. meaning P's true. The first one is P's true, the other two are false. The second one is Q's true, the other two are false. And the third one is R's true, and the other two are false. And then the only other possibility is that all three are false. So basically, guys, the only possibilities there are is they're all true, they're all false, two of them are true and one is false, or one of them is true and the other two are false. Those are my only possibilities. So this is a generic truth table for the very beginning. Okay, now we're going to try to do this one. So we first noticed that we got to find P or Q. So let's write that one down, P or Q. We're going to need a truth table for that. Okay? And then we're going to need a not P or Q. Right? Because we're building ourselves out. That gets us this entire thing here. And then we need our final answer. I'm slowly building out from the inside of the parentheses out. Then I need a not P or Q and R, which is the final statement. So this will be my final answer. So P or Q. Remember with or, as long as one of them is true, we're good to go. So we're right now looking in comparing these two lines right here. So as long as one of them is true or both, my or statement is going to be true. So I have two trues. Let me double. Two trues makes that true. Two trues makes that true for the first two columns. A true and a false is true because one of them's true. True and false is true. False and true is true. False and true is true. False and false is false because not both of them are false. And false is false. Okay, so that's P or Q. Now I need to do a not P or Q. So now I'm just going to put a not in front of anything in this column, which means I just change all of these to the opposite. So this one becomes false, 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 false. This one's opposite, true. And this one's true. Okay, now I'm going to compare. This one's a little tricky. I'm going to do this column. Dang, it's not catching. I'm going to do this column and R because it's not P or Q and R. So it's an and. So, for example, in this one I've got true or false, false or false, true or true. I'm comparing these, right? I'm using these truth values. Remember, with an and, we're in the conjunction right now. We're in the conjunction. And an and statement is only true when both are true. Otherwise, it's false. So in this first case, the very first, this and this, I've got true and false, which means false. Second one, I've got false and false, which means false. Third one, I've got true and false, which means false. Fourth one, I got false and false, which means false. True and false means false. False and false means false. True and true means true. False and true means false. So this is my truth table at the end. So that was kind of a challenging one because there's so many more possibilities here when you have three statements interacting with each other. But it looks like they're all false except for this one case right here. And the only time that this overall statement is true is when P and Q are both false statements, which is really weird. But that's because we have some negating going on, and we've got an or, and we got an and it's just very confusing, but that's how it would work out. Okay, that's the lecture for 3.3. That should get you started on the homeworks.